Yeah, magic. Hello, everyone. My name's Alex Reibman. I am the founder of AgentOps. AgentOps is a monitoring, testing, and observability platform for AI agents. So a bit about my background. Previously was a machine learning engineer, worked a lot in research and fintech, so basically building recommender systems for large banks and writing things like feature stores, data pipelines, so on and so forth. Also kind of a veteran hackathon hacker. You probably see me out here in the San Francisco ecosystem from time to time. Yeah, so what are we going to talk about today? We're going to talk about AI agents. So if you're here, you're probably at least vaguely familiar with what agents are. And kind of what all kicked it off was kind of early last year, about around March, once the API started to hit and GPT-4 started to hit, we started seeing like a few projects pop up. Namely, there was AutoGPT. AutoGPT was essentially like some guy, he was curious about how he could use GPT to make money, so he kept prompting over and over and over again and said, make me money, to the point where it actually became an autonomous agent. There was another really popular repo that came out called Baby AGI. It's actually by a VC named Yohei. And the idea here is you give it a high-level task, and it iteratively creates a plan and task list so that it can solve itself. So it gave it the high-level task of solving world hunger. You can actually watch it execute and try to solve world hunger in life. And so these projects actually gained a lot of attention. I think AutoGPT was the fastest growing repo of all time on GitHub, or at least one of them. And there were a handful of other ones too. So what exactly is an agent? I don't think anyone's like really kind of solidified a definition on this. And I think there's a good reason not to. If we're too solid what the definition is, it kind of constrains it. So kind of the analogy here is we have these like, go outside, you'll see Waymo, you'll see Cruise. We have self-driving cars. Agents are kind of like self-driving programs. You give them a high-level objective, and they actually solve autonomously how to complete an objective, which is really interesting. And in our estimation, it's going to be like the next paradigm shift in computing technology, which is we're no longer going to have to hire software developers to do this stuff for us. We're just going to give high-level objectives to AI agents, and they're going to be able to stitch together tools, APIs, write code, read code, et cetera, to solve these problems themselves. So what does that look like more concretely? Well, here's some pretty cool examples out there that you might have seen. So this is a paper that came out last year called Voyager from a team at NVIDIA and a few other labs. So essentially, they actually taught an AI agent to play this simulated game called Minecraft. Minecraft is like a 3D world where you can build bases and gather resources and fight enemies. And the way that this agent worked was they actually kind of gave the agent full controls over the character, and the agent was actually able to teach itself how to play the game. So in this game, you can do things like gathering resources, like chopping down trees or fighting zombies. In this example here, it actually teaches itself how to fight enemies, right? So it writes the code in Java, the scripting language they use for the agent. It saves it to a skills library, and then when it encounters kind of an enemy or a stimulus in the environment, it knows how to intelligently pick that tool from the skills library and use it to solve its problem. So kind of cool example here. I hope this works. Thank you. Yep, awesome. So like, here's a kind of a cool video of like, if you give it a high level objective, right? This is like the self-driving program part of things. So you say catch fish, and it will go to the nearest pond and pull out the fishing rod and catch the fish. There's no humans playing this, no humans whatsoever, right? And it's just able to autonomously figure out how to solve the objective. Now imagine this. We have these like simulated worlds where you can tell programs to do this stuff. What other scenarios can we apply this to? And this is where we want to unlock the creativity of like, what agents can do. So think beyond video games. Think about writing code, automating work, turning ideas into reality, making robots, automating assembly lines. This is the kind of stuff we need to start thinking about into the age of agents, where it's not just video games and mining rocks. It's about really changing the world state. And that's ultimately what agents are. They're programs that know how to change the world state. So there's kind of like, one of the origin stories was like Karpathy kind of came up with this cool diagram, posted it on Twitter, where we had this LLM OS, where kind of underlying it all, you have like a CPU, that's your LLM, and that does all the reasoning. You can add some sort of memory to it with a context window, but you can also kind of stitch it together with other things that make it interesting. So giving access to the Ethernet, right? Give it a browser. This is kind of where you can start doing a lot more with than just like the core LLM alone. Giving it the ability to read and watch audio and video, the ability to create things in code environments. That's where it becomes very, very powerful very quickly. And this is how we actually envisioned AI agents as kind of like a as an observability layer. So AgentOps, just for context, we're a Python SDK that gives you the ability to track, monitor, and test AI agents by basically stitching together what are the core components that need to be monitored and understand how they're executing live and test. So underlying it all, you have a large language model. So the LLM is kind of like the underlying factor that makes these things function. And I'd say the very, very bare minimum that sets an agent apart from a standard ChatGPT LLM is adding tool calling. So tool/function calls, once you stitch those two things together, that's where it becomes extremely powerful, extremely quickly. That said, there's a lot of other things that we add onto the agents to actually make them more capable. So oftentimes we want to actually give it external memory. So we have the Pinecones of the world that raise gazillions of dollars. And the idea here is that you can build agents with infinite memory. But also you want to actually sometimes have an external planning manager. The LLMs themselves aren't exactly fantastic reasoning engines. So sometimes you want to have an external LLM, like a sidecar LLM that does the reasoning steps for you. And one other cool thing, and we'll show this during the demo, is multi-agent tendency. So we have this this fad going on, and it's actually quite popular with frameworks like Microsoft's AutoGen and Crew AI, is you have actually multiple agents that work together to solve problems. So the idea here is, A, it frees up time in that you can run tasks in parallel, but B, it helps resolve this issue of confusion where the agents basically, there's too much stuff in context and it just falls in circles or fails to do its task. So here's kind of, this is a little more appendixy, but here's kind of some stuff. You can talk about it afterwards if you're curious to kind of break down more about what these core components are all about. So in any case, what are kind of the reasoning engines we've been working with? For the longest time, a lot of this stuff has been just chain of thought prompting, which is you give an agent kind of instructions about how to solve a problem, and that's kind of the best we've been going through. We've been trying some other things where we have you basically load in even more examples. You have self-consistency, which is kind of another way of prompting it so that it can solve problems better. We have this method called trees of thought, where trees of thought, where you basically have these graphs where you have intermediary reasoning steps that help the agent kind of solve problems better. And this is all to kind of solve this problem of agents kind of go in circles. So generally speaking, the agents these days have planning managers attached to them that make it easier to basically not get confused. Let's go here. So anyway, what are the most common AI agent use cases? So if you are a big company or you work for a big company and you want to get a promotion, right? Or you want to make money for your company because you own it. Three biggest things that we've seen enterprises use without fail, text summarization, chat to documentation, and support Q&A. Those things, that's the easiest, lowest hanging fruit, and they have crazy ROI. Especially support Q&A. If anyone's here familiar with Klarna, Klarna is a Swedish buy now, pay later company. They created a support Q&A bot. It not only has higher customer satisfaction rates than their human agents, it's saving them $40 million a year. So this is the kind of stuff that you could be building up, maybe with VoiceFlow, right? So definitely check out, these are three core use cases. One I neglected to mention on this, which I've been seeing a lot of traction coming out recently, is research agents. So basically giving your agent the ability to chat with your databases. So we have a lot of folks using us who are building agents for finance. So they're connecting their agents with their internal research data sets, internal decks, Gartner, Morningstar, so on and so forth, to answer questions about stocks and equities. Anyway, so kind of last underlying all this kind of stuff is how do we create AI agents that are reliable? It all boils down to creating a life cycle for how do you make sure these things are evaluated and tested and benchmarked in a way that they're going to be reliable. The biggest issue with the agents is they're highly non-deterministic. If you've ever tried an agent, trust me, they suck. They're really bad right now. And the only way we're going to be able to do that is be creating a kind of a virtuous cycle. Check out this website, hamel.dev, fantastic blog. This is where I stole it from. The idea here is basically you want to create two kind of core things. Number one, you want to create tests and evals. So kind of understanding how your agents are performing over time. And secondary is you actually want to log all your traces. So the reason why you want to log all your traces is you want to have a history of what your agents were doing over time. But second is the logs will go into the ether and will never have use ever again unless you capture them. So why would you want to capture them? Great answer is fine tuning, right? You can create cheaper, faster, and more effective models based on inputs and outputs that are more consistent with what your users are facing. So really got to make sure that you're capturing your traces every single step of the way. Kind of the other stuff is kind of more along the lines of tweaking AI engineering. It doesn't really matter that much. But really kind of the two core aspects is creating a good test set and being able to capture all that data so that you're able to improve and understand how your systems are evolving over time. Yeah, so if you're actually interested in building agents, I definitely check out these 4 highlighted in green. CrewAI and AutoGen and MetaGPT are all multi-agent frameworks that work unreasonably well at a lot of tasks. MetaGPT is actually probably one of the better coding agents out there. So you've probably all seen Devin. This is probably like, free Devin, for lack of a better word. CrewAI is actually more for kind of like orchestrating like small teams that can do things like search the web, read databases, so on and so forth. There's a plethora of examples on the CrewAI repository. Highly recommend checking them out. They have an integration with AgentOps also. AutoGen as well. That's a little more on the research experimentation side, but we've seen a lot of folks in enterprise who are adopting AutoGen-based agents, and they're using AgentOps as their observability platform as well. Anyway, so this is the part where I say why agents suck. It's just, honestly, if anybody's tried agents, they're not reliable yet. We're very, very early in this phase here, and if you believe that they're going to get better, then you should probably start building them. Anyway, I'm going to skip this stuff. Anyway, so agents suck, we're fixing that. This is the part where I'm going to go into a demo. I'm going to show off, how do we, run an agent? What does an agent look like? And what's a good example? And how do we get observability on that? So this is the part where I go up and sit on the couch. Okay. Oops. Oh, I would appreciate that so much. Oh, okay. All right. Okay, awesome. So I'm going to pull up Cursor here. So for context, this might be hard to read, but I will try my best. All right, so we're going to be playing around with an agent that's built with CrewAI and AgentOps. And the idea here is we're going to create an AI agent system that's able to create job postings for us. So the idea here is we're hiring at AgentOps right now. We're hiring software engineers who are kind of with the latest and greatest in AI. So what we're going to do is we're actually going to stitch together a bunch of agents. So let me just go here. We're going to create 3 agents that work together. We're going to create a research agent. We're going to create a research agent, a writer agent, and a review agent. Let's take a look at what these guys look like. So kind of essentially the way it works is, let's see here, agents. OK, excellent. So agent number 1, our research analyst, will analyze a company website, give it a provided description to extract insights on culture, values, and specific needs. Awesome. We will give a second agent, which will be our writer. It will use the insights from the research agent to create a detailed, engaging, enticing job posting. And then lastly, we will create a review agent. And this is kind of the thing that just condenses everything together and creates our job posting description that we can put on LinkedIn or Indeed.com or Monster, what have you. And kind of the last bit of things is we're going to plug in AgentOps. So the way AgentOps works, it's literally 2 lines of code. If you're building anything in Python that's LLM related, there's very little excuse not to add this because it's just kind of free observability and it makes it way easier to debug. And for context, it's an open source library. If you want to give us a star, we're almost at 1,000. That would be really cool if we can get that soon. And we do all sorts of other things in addition to observability, like cost management, benchmarking, compliance. We have a ton of integrations with the most popular frameworks out there. And it really is just 2 lines of code. We spent a lot of work trying to make it as easy as possible. So anyway, let's run this thing. So let's see here. OK, so I'm going to try to make this as large as possible so that folks in the back are able to see it. All right, Python main.py. OK, so now it's kicking up. So what is the company description? AgentOps build monitoring, cost tracking, evals, and observability for agents to make them not suck. All right, so the agents suck. We're trying to fix that. Company's domain, www.agentops.ai. What are we hiring for? We are hiring for cracked AI engineers who love to build agents. All right, and specific benefits, work with the most talented developers in San Francisco, which is not a lie. All right, so awesome. So what's going to happen now is CrewAI is picking up. So Crew is basically, the way that they set it up is you define these agent abstractions here. So you have the researcher agent, the writer agent, the review agent. And then you just kind of put them in a crew, and you just do crew.kickoff. And basically, 3 agents are going to work together to try to solve this problem. And we're going to see in the console here, this is exactly what happens. So we have all the input here, and it's going to just basically spam my terminal with all this text. And this is kind of like number one why observability is very, very important. Because if you're a developer, this is like impossible to read. I don't know about you guys, but like this is like extremely, extremely difficult to parse through. So kind of like one core aspect why you'd want to add AgentOps is like you don't want to have to read through this text if you're trying to debug a run. So I'm going to go ahead and actually open up a browser now. So at the very beginning, we actually create a little URL here. They can click and launch and see what your session is looking like. So awesome. Here's my session so far. So oops. I'm trying to make it as big as possible so we can all see. I've already spent 15 cents on GPT-4 credits. We can see here that we've done 7 events. And we can see like the LLM chat viewer. So essentially, like instead of having to look at this monstrosity of a chat, we kind of get like a nice formatted thing right here, which is already a huge convenience. Second to that, we can also see the number of LLM calls and the number of tools that were called. So we've actually called three tools so far and 4 LLM calls. We can actually track for repeat thoughts. It's not going on for very long right now, but one common fall through with agents is that they go in circles and they just keep going over and over and over again. We've probably all experienced this. We have kind of like a tracker for this to understand like why are agents falling into loops. And then lastly, we can kind of see like step by step what the agents are doing. I'm going to go ahead and pull up a run that I've run previously. So it's
Is there a circuit breaker if they keep calling and costing us?
Yes, we actually have these special error events. So in case your agent falls into like an infinite cycle, we have kind of like an error exception where you can kind of break the program and make sure that it gets logged to the dashboard, which is like kind of a huge value add. Otherwise, you end up with runs like this that cost $10 in GPT credits. Ouch. And yeah, essentially, here's like one. Yeah, exactly this is what happened. The review specialist basically fell into a loop, and this is probably why it went crazy. I had to actually end up the program manually. So you can see step by step what the agent's actually doing in this like waterfall diagram. So I can see like the tool call was searching a specific website. I can see the LLM call that cost me like 4.5 cents. And I can actually read through all the prompt and text. Lastly, and this is the kind of the tail end of the demo here, is we're going to take a look at like what does like a testing and benchmarking suite look like. So this is kind of like early alpha. If you're actually building agents that are about to be sent to production, please come speak with me. I'd love to kind of give you access to this. The idea here is we've compiled thousands and thousands of eval configs. And the idea here is you can basically figure out which config and which evals are best for your agents, and then run the agents against these tests and see whether they're succeeding or whether they're failing. And that way you can feel confident that they're going to succeed in production. So here's an example config. We actually give this to this is an open source eval dataset called WebArena. We gave WebArena, they basically give us these websites. These are fake sandbox websites you can send an agent on. You give it a high level question like, what is the top selling brand of Q1 2022? If we go to this website, you can actually see like it's like an e-commerce dashboard. Well, it's logged out right now, but the idea here is like the agent could actually go to the dashboard, try to answer the question being, what is the answer to Q1 2022? Answer is Sprite. It failed because it was supposed to be an exact match. So essentially, like going back to the main PowerPoint of things, thank you. Two main things. Number one, you want to capture all your data. You want to trace and observe all your data. It makes it easier to debug these things, but it also, more importantly, makes so you can make cheaper, more reliable models. Second is you actually want to create the evaluation framework, right? You want to make sure you have tests and you want to have benchmarks. That way these things can work effectively, and you can convince your manager that they're not going to fail and cost your company millions of dollars. So anyway, that's it for me. If there's any other questions, I can have time for like 1 or 2. Otherwise, pass it on to the next speaker. Thanks so much. And last but not least, please give us a star on GitHub. We are very, very close to 1,000, so that'd be sick. Any Q&A? Yes?
Is it possible to determine the interactions between the agents, or you don't have control over how they interact?
Yes, so the question was, is it possible to observe and control the interactions between agents? The answer is yes to both. So kind of like the nice part about AgentOps, and maybe I didn't show this as well, is kind of on your dashboard, you have the ability to, I'm going to go back here. Yeah, so we have like, if you define multiple agents in your run, we have like this drop down that actually shows you the agents that you've run in your session. In addition to that, in your waterfall diagram, we actually show events where tasks were delegated between agents and the agents actually communicate with each other. And that way you can kind of visualize, hey, there's multiple actors in this situation here. How do they work together to solve the problem? Yes?
Is there any pricing for this?
Pricing? We make money like many other observability companies. We do the Cloudflare method, which is when you start using us very aggressively, we give you a phone call. So don't worry about it right now. Honestly, like unless you are kind of a Klarna-sized client, you're probably not going to get angry emails from us. But by and large, if you have a kind of a specific use case, happy to chat with you. It's basically usage-based pricing, so it's quite simple with that. There's time for one more question. All right. Yes.
Yeah. Are you also adding features like when you're creating a agent chain, you might be stepping through it manually, or you might not automatically. And often you're experimenting with the chain sequence of chains. So often you need methods to compare which chains that work well, like in terms of match performance.
Yes. Okay. So the question is like when you're creating like agentic workflows that are kind of like chains or methods. I have kind of like a very experimental thing I can show you. I'm glad you asked because I don't normally get to show this thing. Let's see here. Yeah. So this is kind of like an old thing that we built a long time ago. So the idea here is like imagine your agent as kind of like completing a series of steps. So imagine each of these like vertical black bars as a step in a sequence. And this is kind of like Squid Game for agents, where you have like 100% of agents on the left. And then like from phase 0 to phase 1, a bunch of them get killed, right? Because they fail to do the step. So you can basically visualize like step by step how agents are performing steps over time. You can compare like how far along they get into a series of things. So you can imagine this like shopping on Amazon.com. Maybe it's able to open Amazon.com, but is it able to add something to the cart? Is it able to buy something? Is it able to fulfill the order? So on and so forth. So yes, this is like something that a lot of folks are interested in. By and large, I think like it's a little experimental to say everything's going to be graph or execution based right now. The finite state machine that powers FSM or that powers a lot of the agents is still like, I think a lot of folks are kind of working towards like graph-based agents, but it's still super experimental. I'm waiting to see like if more adoption happens. And when that does, we'll probably start kind of leaning into that a bit more. For time being, it's like honestly just getting good logs is like a huge 0 to 1 step. All right, we'll do one more question and then I'll hand it off. Yes? So yes, the question is it only Python or do we do any other languages? The answer is technically yes. So we have a Python SDK, which makes like the magic 2 lines of code thing, but we also have a REST API for those folks who want to use different languages. We had TypeScript for a while, but we ended up kind of retiring it in favor of the REST API. Happy to chat with you on how to get with that going. So yeah, that's it. You've listened to me talk for long enough. Happy to answer any questions. I'll be here for a little bit. Thanks.